Hello, in this video we'll look at AES-GCM encryption in C#. In this case we'll encrypt a little piece of string, nothing too fancy. Now encryption can obviously be used for various messages, and there can be various forms of encryption. This one is a good sort of relatively straightforward thing without using files and keys and all those sort of arrangements. There are more complex arrangements for when you need more security, for when you need to perhaps share and handle those things in a different way. This is a relatively straightforward thing. We generate a key, we encrypt the data, and using that same key and some other bits and pieces of data, we can decrypt the data to its original shape, essentially. If you are interested in some other use cases and some other forms of encryption in C#, specifically take a look at the Revolut course, where you have to use all kinds of files for encryption instead of keys, a bit of a different arrangements. Take a look at that course, take a look at that video as well. But for this, we just need to generate a key. A key in this case is 256-bit key, 32-byte. Right here we state that, and we use something very useful, available in C#.net. We use random number generator for filling those keys. So this isn't like random for generating numbers. This is specifically for generating numbers in terms of bytes, to basically fill some random bytes in that byte array, hence generating a random key. And that key will be stored somewhere or maybe sent to someone so they can use it, decrypt the data that you encrypt. Again, all kinds of appliances for this, applications rather. So we have the string original, and then we will see not the original, but let's start with the actual encryption. Let's jump to this method. This code is available for download in Patreon. There's also other things there, free courses on certain tiers, so do check that out. Kind of an interesting thing, C# related mostly. And here we just basically will provide the key, we'll provide the plain text. In this case, now it could be some kind of a file data. It doesn't have to be the plain text. In this case, we're just using it as example, but essentially what we do need is the byte array. So whatever byte array you have, you can certainly go ahead and encrypt it. It doesn't have to be like this, the text. You can get the bytes prior to this. Again, all kinds of arrangements here, but the main point is to get to those bytes, the byte array that you actually want to encrypt. Now, before that, for the actual encryption, we need to construct AES-GCM. That comes from System Security Cryptography. So if we go a bit upwards right here, the main thing that we're using for the actual encryption is System Security Cryptography. We also use System Text in this case, but that is mostly for doing something like this, encoding, getting bytes, and then from bytes getting text. So just so we have that example. But basically, for the encryption, we are using this System Security Cryptography, and it can be random generator or something like that. So we construct ACM, GCM. Now, this is somewhat an interesting thing. We provide the key, and it used to be in the previous version, shall we say, key was enough, but now we also need to put the tag size in bytes. That is important for some security reasons and in general. So you do need to provide that. If you don't, it will show like this, basically deprecated. So this arrangement is deprecated. It should still work essentially, but we are better off providing the tag size in byte array. So this is the tag size that will be actually sort of created. You'll see that a bit later, how it gets created. So other than that, we create this nonce. There are a few things that work here. We have the key, we have then the nonce. The nonces, again, need to be stored once created, so they do get created from the encryption, sort of. They are assigned to the encryption, so you need to store several things. You can possibly store the key in your database, in your field, or rather maybe the key comes from the user, and then you store the nouns in your database, in your arrangement. So all kinds of things, basically to separate some of this stuff so it's not all in one place, makes it a bit more secure, basically speaking. Now, this in this case, we use max size. We could also put a number, like here we're not using max size, but we are using specific number. Generally, I would recommend using max size, although in case it changes, it shouldn't. Perhaps sometimes a better idea would be to actually put the actual number. You can look up, you can do a little debug session and look up what the max size is and do it that way. So if we run this just quickly, you'll actually be able to see some of the results. So in this case, the max size is set to 12, so you can just set the max size to 12 in case at some point the max size actually changes, it changes a version, it might get messed up. It may not, it probably won't be that, but again, this is a library that someone might change and you might update, so just something to think about in terms of some of these things. And other than that, we just use the same random number generator, and we can actually run the program fully just to take a look at the result, what we are getting. We'll get to that later, but basically this is the original message, and then this is our encrypted message. Obviously, it's unrecognizable. In order to get back to that original form of the message, whatever it is, whatever the data is, it can be decrypted, so it needs to be decrypted. Otherwise, it's all secure. You have your key, then you can read it. If you don't have a key, well, you're not allowed to read it. Very simple. So we get the plain bytes, we get the ciphertext. Ciphertext will be, well, the ciphertext that we will actually receive. So that is the hashed sort of, not hashed, but encrypted in this case, piece of data. Again, comparison to hashes, encryption, you can actually decrypt with a key, get back to the original state, read the data. With hashing, you just have the representation of the data, a signature of the data. You cannot get back to that original state. You can only compare those pieces of data, whether they match or not, like a signature, right? In encryption, you can decrypt it and read the original. So after that, basically, we get all these pieces of information. We get our ciphertext variable, really. We're not creating a ciphertext here. We're just getting the byte length, so all that encrypted stuff will be outputted in ciphertext right here. And then we use from AES-GCM construct, we use Encrypt, and then we provide the nouns, so we provide the plain bytes, we provide the ciphertext for us to get that result into that, and then we have the tag. The tag is also created like this, but as you can see, there's no actual filling of the byte, so it will be filled inside this encrypt method, and it will essentially be returned as such, right? Relatively straightforward thing. But all that data you will need to securely store somewhere. Some of it may be sent to somewhere, or maybe the key will actually be provided by the user. That is also possible to do, so it might be a password, might be something of that nature. And again, there are other options available. Some of them are easier to use, some of them are harder to use, but this is basically how you encrypt the data. So remember, we had to set the size, plain byte size 16, then we have here 16 as well, the tag size. Those sizes obviously need to match for decryption as well. Now, getting to decryption, again, we construct the same AES-GCM thing from system cryptography. And of course, the size needs to match. Again, it's very important for the size to match. If you create something like this, it doesn't work, there's some weird error, make sure those sizes match. That's the first thing you should do when debugging these arrangements. Other than that, we have the ciphertext, which will be the same length as the decrypted text, because we set that same length. So it will be the same length, and then we decrypt. For decryption, we need the nouns. We need the ciphertext, of course, that's what we are decrypting. And then we have the tag, and then we have the decrypted, which will be the actual output. So this will be that piece of text, the original piece of text, and then of course we use system encoding UTF-8, get string. From byte array we get that little thing. And again, there are many other options for encrypting stuff. This is a relatively secure way to do it, a relatively straightforward way to do it. The important thing here is really how you store those keys, how you store those nonces, how you store those tags. That is the important part. If you do not store them securely, then there's no point in encrypting it. There is probably some point in it, but if it can be broken into that way, well, you're leaving the back door open, so it's not good enough. You need to make sure to store them properly. And with that said, we will conclude this video.